Hello, my name is Anthony Johnson. I am an engineer first, and I have built several systems at both big companies and small companies building observability systems. My latest big observability system was an Elasticsearch system, and ran into a ton of challenges with that. And so today I specifically want to talk about how Scalyr, this is a company that I just joined, competes against Elasticsearch to solve essentially all of the challenges that I faced at my last company. And I believe that these challenges are not unique, and I believe that there are ones, hopefully, that this video will bring you a lot of clarity to. So to begin with, to understand Elasticsearch, we first have to understand how it's built. And so Elasticsearch itself really starts with, like any system, with where we put the data. And this data essentially comes in where we need to be able to write the data, and we need to be able to read the data. But within Elasticsearch's world, these all get contained within what's called a data node. And the data node is where all of the data is stored for a particular index or a particular shard in this case, and we'll get into indexes and shards in just a second. But the way you scale out your Elasticsearch cluster is you essentially add more of these. Scalability comes by adding more places to put the data, and that data is essentially a computer node. The data within this one is stored as indexes. And so if we look at an index essentially will look like, imagine that these are events, and we have keywords. I like Fred and George. Those are good guys. And you have to imagine that we look at this index and we reference exactly where Fred and George are stored within this content. And so by using the index, I can tell you what events Fred is actually in and what events George is in, and also what events George and Fred are not in and where they're both in. And to make this scale, because an index generally is considered to be kind of a file, to make this scale, we end up doing shards. And so what you can do is you can imagine that we break this into multiple sections itself, and those multiple sections themselves can be stored within one of these data nodes. And that's how Elasticsearch essentially scales, is by creating these indexes, dividing them into shards, and then distributing those shards across data nodes. Most systems, observability systems, will consist of essentially an ingest pipeline. So you have to imagine having I like to imagine it as a funnel, and we will call it the magical ingest. And this ingest has to take data from all sorts of places. The traditional places are your runtimes. And runtimes can be your applications, these can be logs, and I like to think about these as conveyor belts. We also have things coming from your infra, and your infra is, it could be your network, could be a whole bunch of different things. Modern things also have cloud. These will be your AWS logs, your services, things like that. And then the much more newer is bringing these things in from shared buses, things like Kafka. And all of these events come into this ingest system where we gain flexibility to that ingest system. They are enriched, they are transformed, and ultimately they get written through this write path into a data node and distributed. So this itself seems pretty good. And the way but we also have consumers of this data. So you have to imagine that we are going to have applications that are custom applications that are essentially going to use APIs to read and write to this data. On the other side, we also have pre-built applications. In the Elasticsearch world, Kibana is very, 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 very popular for being able to read data out. We also have Grafana. And we also have Tableau is a very popular one as well. And so, depending on which one you pick depends a lot on your use case as well, because these systems all have their limitation in some way. Kibana is highly paired with Elasticsearch's ecosystem. Grafana offers sort of a middle ground where it can do everything to everybody, and Tableau really has opinionated ways on how it talks to its data systems. But all three are viable ways to talk to your systems. In the last observability system, we used all of those, and we started to end up with some challenges with all of the different things that were in motion. The first one was obviously the number of events that were coming in, and these events they're not all the same. Each of them has a different number of fields. And since we're indexing, we have to pay attention to all those fields because some of them are going to be some of them are we're going to have to extract keywords from them, some of them are not. And of course, all of these events, they get packaged up into indexes. And depending on the amount of data coming in, you may have 5 indexes, you may have hundreds of indexes. You have to pay attention to those. And then finally, those indexes get divided up into shards that get distributed across your entire cluster. And moving on, that's just the data side. We also have to worry about our infra. And so with the infra, the most obvious is paying attention to disk. And that's the one that a lot of people pay attention to. When I was first setting out to build this, this last observability system, I got fast disk, thousands and thousands, 100,000 IOPS a second, thinking that that was going to be the big issue. But really what comes into play a lot with Elasticsearch is the network. And the network comes into play because of the design. Your data is distributed across all these different nodes, and data comes in, an event comes in, you don't just write it to that node, you also write it to a replica. Or maybe it's not even supposed to be on that node, so you copy it to another node. So the network is definitely in play. And CPUs our limits to the disk are in a lot of ways limited by the amount of CPUs we have. And so every write thread maxes out at the number of CPUs. And so you really come into your quality of your CPU. And a faster CPU can write to your disk faster, and you're not waiting. So you also have to pay attention to the quality. And then finally, we have our number of nodes and on how we write into the cluster. Because essentially, if you have data coming in, you're dividing into shards. If you send all of those shards to one single node, that node's going to get overloaded, and you're not going to be able to write to it. And so the next real dimension that we have to pay attention to is our consumption. And I think this one is often overlooked. It's intentionally read on purpose, specifically because it's the most volatile. It's the one that's the one that's most out of your control, which, we talk about your number of users that come into the system, specifically how they use the system, so their usage of the system. Are they running a bunch of queries all at the same time that are just not optimized? You can train, but you really can't keep those users themselves in the most amazing way. And then the last part of it really is sort of your SLA to the user. And so are these users themselves thinking that their queries are going to come back in 20 seconds and 30 seconds and 5 seconds? What happens when a query doesn't come back at all? And we run into a lot of risk at these. But when you end up with all of these sort of dimensions that you have to care about, you end up in sort of this spiral effect, where first you're worrying about your data, and then you start thinking about your infrastructure and how that's going to scale to meet the events coming in. And then of course, throw in the users, and it just gets worse and worse and worse. And so what ends up happening is, a change in your data means you have to change your infrastructure. But a change in your data also may mean that the user themselves start behaving differently, which means that you get different types of events coming in, and then also different types of infrastructure as well. And so you end up in this spiral effect where you're just always optimizing and never really being able to get the global optimization of this central system that it promises. So the spiral was a huge part of my problems, because when one problem failed, it wasn't just that I couldn't deliver search results. The problem was I still had all these events coming in at maybe 10,000, 100,000 events a second. And so what ended up happening was things started building up. And this buildup really became painful, because what that buildup meant was message delay. And message delay is purely seen by the end users. And those end users, as I'm a central observability team, they are, they're my customers inside this company. They're people who are depending on my data to make sure that they can figure out what's wrong with their applications or figure out how to make the right business decision to move forward. And so, people in the business felt it. And so I needed a way to solve this problem easily. And honestly, I looked and I really couldn't find one until I found Scalyr, and I got really, really excited. And here I find myself in the company. So to begin with, how does Scalyr solve this? Scalyr solves this by being cloud native to begin with. And so we still have our writes into the system, like any system, and we still have our reads out of the system. And what Scalyr does is it is completely cloud native, and it is also index free. And so you have to imagine that they are storing data into a modern object store. But what they've also built, because good engineering is not to write the same code twice, just like that, we don't want to run the same query twice as well. So we created basically a summary of that data. And so this summary essentially self-optimizes, pulls data out, looks at your question, and basically says, you know what, they keep running this question a lot. So why should we ever run this one again? And so together, this very simplified view is the Event Data Cloud. Now there's a whole lot of other optimizations we do. Horizontal scheduling, multi-tenant architecture where we're sharing all of the hardware for all of our customers. But at the end of the day, we want to take as much of the grief away from you as possible. And so, by this being a true cloud offering, we can solve a lot of these challenges over here. So, your number of events coming in, you don't need to worry about. That's our problem. So, number of fields, we handle that. Number of indexes, number of shards, there are no indexes, no shards. It's just data. So we handle this one as well. Infrastructure, unlike a lot of existing cloud services, Elastic Cloud as well, you don't have to see it. You don't have to care about the disk. No caring about the disk, no caring about the network, no caring about the CPU, the quality of the CPU, not even worrying about upgrades. And then consumptions, your users are our users. So when we get down to your number of users, their usage, and the SLA, their SLA is our SLA. We take care of that as well, which is something you won't find with other cloud offerings. It's a support ticket where for us, we handle it, we lay out the data, we take care of the hardware, and we make that problem go away. So, but there's still another challenge here. The challenge is you've invested a lot of time and money in making this observability platform. You may have just launched it 6 months ago and started hitting these scaling issues where 10,000 events a second or 100,000 events a second, you're just starting to find delays, or you're starting to find that you need 100 nodes to be able to support your data types or your retention. And so how can we make this work? Well, for us, it really gets into integrations. How do we make sure that we make this as easy and efficient as possible? So, tools like Grafana, these guys can come right to us. Your ingest, like all good systems, you can dual publish. And so you can start having data coming to both of these systems. And that really makes it pretty effortlessly to begin with. But we also said, well, wait a minute. What about your applications that are using these APIs? What about Kibana? Maybe you love Kibana. Maybe you've had people come and do training for Kibana. And so we wanted to make sure that we could provide sort of an effortless transition to that as well. So we actually have built, what we call is our ES connector. And the ES connector itself is basically just a translator. So you send data this way, and we will send the responses this way. And this integrates natively with Elasticsearch and its cross-cluster search. The advantage of this one is that you can still speak, Kibana can still speak to this Elasticsearch cluster. You've essentially exported data off into the Scalyr Event Data Cloud. And now all of those, you don't even have to do it. Your users should not even notice the difference for most of the use cases using Kibana. Same with your applications. The reads can come here. Elasticsearch can dispatch it to Scalyr. Scalyr can deliver the result seamlessly. And then those applications actually don't even have to be rewritten, and they can go on. Of course, we do want you to start using, we think our system is the best. We do want you to eventually port all that data there, but the point is that you can get started today without having to really rewrite very many lines of code, run a Docker container, and you're ready to start solving all of your grievances that you have. So at the end of the day, the Scalyr system is what I wanted. When I joined Scalyr, the system itself didn't actually exist, so I worked with the engineers there to basically make it to existence. All the parts were already there, we just needed to package it in a neat way. So what we have is a way to move data from Elasticsearch to Scalyr. We have a way to provide portability of the Kibana APIs and your application APIs you've already written to talk to Scalyr. And so now that you've done that, really you can get away of all the grievances, the 5 a.m. calls of just data not working, or the backlog of an amazing amount of data that just needs to get processed in Elasticsearch. And instead, what you can focus on is your end users, making sure that those end users are getting the answers to the questions they need. I'm Anthony Johnson. I now work at Scalyr. And please visit scalyr.com to learn more, or feel free to reach out directly. Thank you.